So now we have got a panel for you. So we've got Jan, co-founder and CEO of Coeb, Duncan, co-founder and CTO of SuperDuper, Ben, co-founder and COO of Superlinked, as a panel, which is going to be moderated by our very own Maxwell Nardi, and we're going to be talking about the emergence of the AI engineer. Please give a loud round of applause for the panel and the moderator.
All right. Good afternoon. Can everyone hear me? Great. Thank you all for coming. Very excited to be hosting this. I guess we can start off with brief intros. I'm Max. I help run our MongoDB Ventures team. So we specifically focus on investing in and deeply partnering with companies which MongoDB kind of works with. So both Coeb and SuperDuper are investments, and Superlinked maybe down the road, but definitely good partners. And we wanted to kind of bring together a group of founders to kind of give a broader, higher level perspective on what we see happening in the market around AI, and specifically what we see happening with the engineering role and how it's evolving, and how their companies are kind of contributing to that and helping with that shift. So yeah, I guess if you guys want to start off with a quick intro of your background and what your company does.
Yeah, sure. So I'm Jan. I'm one of the co-founders and the CEO of a company called Coeb. To make it simple, we're a cloud service provider. So we let our users, developers, and businesses deploy both web apps, classical APIs, and inferencing workloads backed by high-performance accelerators like GPU from NVIDIA, to not name them, and alternative GPUs. And so my background is in infrastructure in general. I spent the last 14 years building cloud infrastructure providers, and including infrastructure to support AI workloads.
Yeah, hi. Firstly, thank you for having us, hosting us here. We're very appreciative of the collaboration with MongoDB. We're SuperDuper, so I'm the CTO, and we are an AI data application builder and platform. So we have an open source offering on GitHub, which allows you to essentially put together very complex and difficult AI workflows involving disparate data sources and also your favorite database, and of course MongoDB. And once you're happy with the results, you can essentially export this to a format. We call it the SuperDuper protocol, and this becomes a portable program, a portable artifact, which you can deploy on our enterprise platform, which runs on Kubernetes on-prem, and will allow you to deploy these applications at scale. So it includes everything from vector search to RAG to much more complicated and involved workflows involving recursive loops between documents and an LLM, and yeah, so that's what we do.
Cool. Hi everyone. A super panel, you can say.
Yeah, there were two supers.
Two supers on the panel. So hi, I'm Ben, originally a software engineer, but now more on the commercial and operations side of things at Superlinked, so all the hard technical questions to them. So our goal is actually to enable the AI engineers. All we do is turning complex data into vector embeddings to help people work with vector search and launch applications powered by vector search. We are based in the US, but have offices in 4 continents. which is quite funny for a small startup. We raised our seed round from Index last year, or led by Index last year. Yeah, excited to be here. Let's talk about it.
Awesome. Let's dive in. So I guess overarchingly, if you look at the history of AI and how applications were built around it, historically it was very much a process where it required an ML engineer, someone with kind of deep expertise in how to build and enable models. But with this emergence of foundation models, and specifically generative foundation models, there's been this large shift where no longer do you need just an ML engineer to do this, but actually like generative models are so core to many of the applications of the future that the normal, or not normal, but just different software engineer persona that was typically more focused on the full stack and the infra or the front end is now having to deal with these models and implementing them and building them. And with that, there's kind of been this concept of the AI engineer, which is this engineer that used to be a full stack engineer and now is having to deal with and wrangle these models. And I'm curious, like, just to start with, are you guys seeing this paradigm in reality in the market? And like, how, I guess, do you see the engineering role shifting right now?
Yeah, I mean, so on our end, on the infrastructure side, I would say it's totally the case. Like our users are not necessarily like MLOps engineer. Probably like if you were to sell like GPU 5 years ago, you would talk to an MLOps team, an ML team or a data science team. Now, I think like the data science is, which was already a specialization, I would say, is one side. Like. And we're talking with full stack engineers which are trying to RAG and use LLM. So I'd say from our end it's the case, and even if you look at our expertise on the infra side, we had to enter this space. Our expertise is not in data science or in machine learning, it's in infrastructure, but we have to understand the stack above to be able to talk to our users. So I would say we're also affected in the fact that we need to learn to talk to these new users. So that's on our end.
Sure. Are we always going to go around this way? Or
I mean,
kind of
no. If you have strong things to say, chime in. If you don't,
right, maybe the first round, then we can like.
Yeah.
Okay. Yeah. So, AI engineer. I mean, in some sense, it's a big ask. So we have suddenly a huge number of new tools on the block, and of course, it means that software engineering is going to change. So every application you might have built without an LLM now can involve, or probably will involve, an LLM in the future in the development process, but also in deployment. So actually, the code will potentially involve invocations to LLMs, and not just LLMs. I mean, the full gamut of AI applications, which we should remember is not just LLMs. And in some sense, this is sort of a difficult development. So hiring is difficult. So for instance, inside our company, we couldn't retool regular software developers well to do what we're doing. So there's kind of knowledge, like some unspecified knowledge in understanding why we build these workflows, why do we do things this way, that it only works with sort of people who've been across the full spectrum of skills from deploying APIs, training models, building MLOps pipelines, and also having the software development skills to actually be able to build what we're building. And in some sense, that's an unacceptable state of affairs for the future. And so my hope in building what we're building is that we can rename the framework "You shall dabble no more," because in some sense, software engineers are required to do things all over the spectrum, and what we'd rather have is to actually maintain the hats. At least this is my perspective: is to maintain the hats that we've had in the past as software engineer, developer, data scientist, infrastructure engineer, and not to require AI engineers to be all over the shop. So to be on evaluation, to be on writing classes, to be on deploying things, in the cloud and so forth, because it's not sustainable, it's not possible, and you're going to get lower quality by having less specialization. So we'd rather create a platform, and I guess this is a little bit what you guys are doing too, is create a platform which allows people to stay in their lane, So software developers are going to be building nice classes which can interact with these tools and going to be using their best practices and standards of software development to build those tools. And data scientists are going to be evaluating and parameterizing and testing these tools locally. And infrastructure are going to be setting up systems that don't require, and this is my experience in the past, don't require me to, in some sense, have to learn the full set of cloud technologies in order to even get something into a prototype. So I'd rather just have a platform that allows me to take what I've tested and just deploy it. Yeah, so I guess... Yeah.
This is what we do.
Yeah,
So our whole ethos is about empowering the software engineer who has interest in solving challenges with LLMs, vector search, to do it without really understanding the underlying technologies that much, right? So we developed a language that they can use that abstracts away a lot of the complexity. We help them bring in structured data into the vector embedding so that they don't need to train a model to deal with that, or kind of re-ranking model, which is kind of the standard in the world. And then we also provide them tool to actually deploy the application to the cloud, right? To create the APIs, to compile to Spark, so they can, as long as they know Python and learn the language, they can actually build the application pretty easily and test it on test data in a notebook and then deploy it to production at scale very fast. We already have the open source solution that we have some engineers working with, and we are building our managed cloud, should be released before the end of the year. But the idea is, again, we have regular software engineer building, with our support at this point in time, choosing the right model, etc., but building a real-time recommender system across millions of items, right, or millions of users, and couple of days of work, testing, and deploying to production. In the future, we want to actually have recipes or even templates where you say, well, I want to build this, and then you just choose your right parameters, you connect your data sources, you choose the model, or we recommend the model that fits that particular use case, and then you just, in one click, launch into production. So that's the future for us.
Yeah. A common thing I heard is like, okay, this role is shifting. I guess within this kind of evolving stack of new tools that people are going to have to learn and understand, like for this audience that's thinking like, okay, I want to be able to build a successful AI application and productionize it and make it work really well. Do you have any recommendations around what tools or skill sets they should really be honing in on, learning, and really like mastering in order to build these applications?
I think the answer is you look at Twitter from last week.
Yeah.
I'm just kidding. Because it's changing every week. So, and that's like one of the things, like since we are in this space, the pace of change is, and that's what is impressive and actually that's why there is probably like a new role, because there is a bunch of new tools, which if you look back like 1 year ago, they didn't exist.
Yeah.
So, we're honestly like on our infrastructure side trying to keep pace, even with the model, like which are varying in size from like, I don't know, a 1 billion parameter to 400. And so what we see is actually that the larger models are not the best performing ones.
Yeah.
From a pure infrastructure side, and the larger ones are the one which needs the most resources. But the tendency is to use highly specialized models. That's one thing we see purely on like the discussion we have with our users, and then had a set of tools to do RAG. Like honestly, RAG is a keyword which I'm hearing the most in all customer discussion I have. So, and then there are competing frameworks. So
yeah.
on who is the right framework to do RAG, what is the right platform. We feel that like there is going to be a set of MLOps platform which are going to make it all easy, interacting with your data source, so that like if you're not an MLOps company, you don't have to build the tooling. So I think there is already a set to pick from. I don't have specific names on my end, I think you are actually building MLOps platforms in a way. You are simplifying this part. We're below this, so we're pretty agnostic of the tooling itself, and we're just trying to keep pace with it, I would say.
I assume you spent, though, given you're offering like GPUs and that sort of stuff, you spent some time mastering like CUDA and all the basics of.
Yeah, I mean we don't necessarily go too so deep. So we run like inference engines. So you have VLLM, for instance, which is it wasn't clear like several months ago, but apparently I think it's going to win as an open source technology to run agnostically LLMs. You have TGI for NVIDIA, but like if you look at something which is portable and pure infrastructure, it's probably like going to be VLLM because other chip manufacturers are adapting there. So that's for me a standard which is going to stay from what we see at this stage. But then like it's also a bit more fragmented if you look at different modalities of models. VLLM is a clear winner for LLMs. For the other kind of models, I'm not sure. Like today, it's highly dominated by NVIDIA, and they have their own distributions for this of inferencing engines. So, but I think it's going to still shift a bit to standardize, and we see like people trying to actually build abstraction layer to help the emergence of alternative chips. That's one of the things we see right now.
Makes sense.
Nice. Yeah. So, so what was the question again?
Tools and kind of skills that you should be focused on learning.
Yes, of course, yes.
To be an AI
I mean,
engineer.
so maybe it's easier to switch it around. What tools should I not focus on, or what?
Yeah.
I mean, what we don't want to end up with is like people sort of getting, painted into a corner in some sense. So there are like very important tools on the landscape of enterprise software like SAP and so forth, where now because it's so established, it makes sense to be an SAP engineer. But maybe it's not such a great idea to become a LangChain engineer. So because even though it might be a way to land a job right now, maybe this tool won't be around. Maybe you might call yourself an OpenAI client API expert or something, but maybe they'll die because of the newest open source models. Who knows? So I would say sort of go to first principles. What's going to have a chance? So I was going to mention later. So there's the Llama stack, which was released by Meta, which is conceived to be sort of an operating system for large language models and Gen AI, and maybe seeking out these tools that you believe have the chance to go the distance. And I think the open source approach, so focusing on tools which really are bona fide open source, these are going to have legs in the long run because, for obvious reasons. If we have great open source tooling, like we have now great open source databases, it's definitely going to be meaningful to know those in terms of how you reskill and make yourself ready for what's coming. Yeah, and learn super duper. Because I'm kidding.
Fair enough.
And so we really try and follow this philosophy to the number. And we have a fully open licensing model, and we allow developers to build applications which are flexible enough to use anything from the ecosystem. And in terms of VLLM, so VLLM is a key integration of ours, but we don't wed the user to VLLM. So, and on our enterprise, we integrate with Ray, which is another beautiful open source project. And in terms of synergy starting to develop, so VLLM deploys to Ray if you like, and then you can use so VLLM is essentially an algorithm. It's called paginated attention, which makes it super fast to sort of look back far into the history of your document, and then you can take that algorithm and deploy it on whatever. And so Ray makes it easy to do that. And so many levels, many pieces to know, but that's an example there. So a nice synergy of tooling developing, and definitely worth following in your path.
Yeah, I mean, so the hope that they would not need to learn a lot of new tools and a lot of new techniques coming into the future. I think at the moment, there is definitely some need to understanding what the right model for the right use case, how to get the data where you need to. A lot of companies we speak with actually, don't even have the data in the right place or don't have the ability to bring the data in a timely manner, right? Clean the data. That's a lot of, very much software engineering tasks. And then, of course, for your particular use case, which model is most interesting? At the moment, right, it's you choose the model, you decide with which one to work. We want to create recipes for most common use cases. And we also definitely keep the finger on the pulse of what's coming out. So for example, Colpali recently made quite a significant advancement in terms of processing PDFs, right, supporting RAG use cases. We're in process of integrating that into Superlink, so you can just use it out of the box. You don't need to understand how it works, etc. We already have a deployment with a client. So ideally, in the future, whatever is the most advanced, most suitable for a particular use case, you can just use the concept we call space. Space is a way to embed a particular type of data and put it in as part of a vector embedding. So we bring those models into spaces. But yeah, at the moment, you want to know what's happening, you want to know what fits best your use case. And of course, you want to understand your own users and know what's more important for them.
Yeah, yeah. I guess there's even the small things of choosing a model, there just seems to be so much uncertainty and developer discourse about like what is the right model for the right use case with the right kind of cost and latency requirements. So that things do seem to be shifting very quickly. I guess on this note, it seems that with the AI application, you have a few new things kind of introduced into the development paradigm of like model selection, prompting, evaluation of the outputs. And a lot of these things aren't necessarily clear-cut engineering tasks, right? Like prompting, a lot of that is just understanding your user and like being able to adjust based on what your user wants. Or like evaluations, a lot of these are subjective metrics of like model trustworthiness or like hallucinations. So on that note, like things like prompting or model choosing or evaluation, do you all see them as falling under the engineer, the purely software engineer? Or do you think that someone on the product side will kind of contribute more to that decision, or say on the like SRE side, maybe around like the observability decision of like, is the model drifting and starting to give less trustworthy responses? Because I guess this does seem like a lot to just put on one engineer or a team of engineers.
Yeah, I mean, we see like, and even as part of our customer, like a platform which are actually observability platform for LLMs. Like, I think this is like an industry which is going or a set of like tools and platform which are highly specialized, which you need like in terms of both because there are a set of problems which come with LLMs which requires tooling. So I don't know actually on the open source side what is there and what does exist. We see like closed source company operating businesses around typically like protecting against prompt injection, or like making sure you measure like the accuracy of your LLMs. This kind of topics are essential, and I don't believe that anybody should try to solve them themselves, except if it's their business, or if the products out there are not mature enough. But this kind of tooling is probably essential, especially like in customer-facing cases. If you have a customer-facing application which requires where you're using an LLM under it, I think you should probably be equipped with this kind of tooling. And I think I'm not completely on your question, but typically that's where I'm not expecting an AI engineer to solve everything, because the spectrum of challenges which are created by the technology themselves is broad. That would be my take.
Yeah. So I mean, the engineer part sort of has the connotation of you build it, and then the sort of evaluation that tends, historically to have fallen into the the pot of a data scientist or maybe more on the product side. So, but in terms of evaluating these applications, there's two aspects. There's sort of reliability, trustworthiness, computer security, leaks and so forth. There's that aspect, and then there's the sort of accuracy, and these things can cut in opposite directions in some sense, because by putting constraints on the model, you're actually decreasing its accuracy just because you're taking information out of the response. So yeah, and so there are a number of tools in open source for doing this, but I'd sort of like to return to my vision at the beginning, that although now evaluating Gen AI is much more difficult than evaluating a regression model, still the principle is the same, which is you have a model which is transforming one type of data into another type of data, and you have the task of knowing if that's good or not. And before Gen AI came out, we had the same problem with recommendations or search results or some kind of computer vision based tagging, that unless you had the ground truth, it was hard to evaluate. So you would have to have someone sit down and go through the answers. So what we need in those cases is for the data scientists to be in a situation where they can deploy evaluation at the click of a button, but under the hood, there are going to be people who are available to do this work. And we've had Amazon Mechanical Turk for years, and there are other more abstracted, polished services for doing this. But I think that the data scientists should put their statistics hat on, take the outputs of a model, and deploy rigorous scientific methods to evaluate quality and safety and so forth, and come up with a leaderboard and metrics which have robustness and real future-proofness in the process. So, but obviously the implementation and whether those tools are even available is another question. But, so go back to first principles, and if you do need to evaluate your models, just what is the scientifically correct evaluation of this prediction, rather than what are the cool tools available, in some sense.
Yeah, totally agree. And by the way, the emergence of AI engineer doesn't mean that data scientists won't be needed anymore, right?
Yeah,
so we do believe that there's 10x more developers at least than data scientists. So for 20% of the tasks, those are the more complex, the evaluation of the model, the hallucinations, yeah, get a data scientist to work on it with a scientific method. Totally agree. However, 80% of the tasks probably don't have those edge cases or those levels of risk that require a very rigorous evaluation process, and there you can go to one of those benchmarks and choose the models that perform best and just use them in your application, because maybe the impact is not that significant if the model is not the best. One other part of this is that we actually the way we enable the creation or generation of the vector embeddings is that you can actually split the unstructured data from the structured data, and that gives you more control, because if there is a particular structured data within the text, like revenue numbers in a PDF, you can query it separately, you can give it separate weight, you can also understand on the explainability, observability side of things, which part of the vector embeddings actually generated the result. And we provide this information in terms of the percentage of the weights between the different parts of the vector. So we do provide some of the tools, but again, for some very specialized tasks, very high risk, high value, still data scientists. That's good. We need them.
So maybe we can do a follow-up. So I would venture that there is no LLM in production which doesn't require sort of fairly stringent guardrails, just due to the fact what's in the model. There's a lot of liability, that, especially if you're doing something like a RAG system, which refers to company documents, which is not a fringe case, but it's actually meat and potatoes LLM tech in 2024. There's so much liability there, just due to the fact you have a free associating LLM regurgitating information out of documents, and if that's going to do anything in your company of value, communicate with different parties, then there's so much you have to do, and not just on the data science side, but on permissions, like for instance. So that's why we sort of make the database a central piece in the AI stack as we see it in the future, because the same things you can do with a database, like set permissions, set groups, set levels of access. If you combine your database system with your model system, you can actually do sort of permissions level, user level permissions with regard to models and which documents can they access in the runtime. So, like there's a lot. So I'm saying the devil's in the details, and the details are there every single time.
But if you do a recommender system for e-commerce or an hotel search, maybe you don't care about that much.
Yeah, so, Sure.
So and those are real cases that we've been.
But on that point, recommending. So there are even there concerns around privacy. So when I log into my profile on whichever e-commerce website, the recommendations tell story. Is that the story you want to tell with the predictions that you're presenting to your users and so forth? So there's a lot. Even so, just a few bits of information allow you to, essentially parcellate, hugely high-dimensional space into a much smaller volume. So, yeah, okay.
No, so I mean, I guess on this note, I would love to hear about use cases that you're actually seeing in production around AI. And specifically, like, what are you seeing is feasible right now for an engineer to build and put out there and like successfully run that's an AI application? On the other hand, what are you seeing that's unsuccessful or not working, if anything?
Yeah, so I think just this discussion is an example of the fact that you're not going to see a specialization of people. It's just there is too much knowledge and too much specifics, so the problems are the same in a way than traditional computer science. But you're seeing a spectrum which is extremely large. That's one thing. And so in the use cases we see typically one of the use cases because we're on the infra side, so we're seeing both nascent use cases and mature use cases. And to be honest, if you look at AI in general, the most mature use case are computer vision, because this exists since 10 years. And so there is a generation of companies who build computer vision products which are mature and which are used everywhere. So this is probably where you have the most mature use cases and at scale. Audio transcription is one obvious one, where now it has been combined from speech to text to analysis with LLM and summarization features on actionability of your transcript. So these are the kinds of use cases which do exist today at scale. And then LLM, you have some people who master it already. So typically, this company who already integrated them quickly, especially if they had an AI background, because it's easier for them to work with these technologies. And you have a long tail of companies trying to use LLM, to use RAG, and to actually add value to their existing processes and to the knowledge they have inside of their company. That's what we see in the customer discussion. And so, yeah, with a huge variability in terms of adoption, where if it's not an AI intensive or native company, we call them this way, because it's we have companies which are fine-tuning models on us as we're providing GPUs. That's one set of users, and then you have a lot of companies which are not going to fine-tune models in the short term because they probably don't need it, and are going to use RAG or this kind of technologies. And it's probably going to be enough for a while before they actually need to fine-tune something.
Yeah, maybe you want to take this?
Sure. So RAG definitely is kind of number one use case for everyone.
Yeah.
I think also as a kind of a bit of a pilot internally to show the capabilities. Oh, this is what we can do. So RAG is definitely number one, but more and more we see free text search companies looking to introduce free text search over their data, right? And that's kind of driven by ChatGPT, right? We've been reading about Algolia CTO saying that after ChatGPT was introduced, there's twice as many keywords in the search boxes that they power, mostly across e-commerce websites, right? So people want to search the same way they talk to ChatGPT, give me this thing that helps me with this, and obviously companies are not ready for that. So free text search is becoming an interesting use case. Analytics, we see a lot. Vector search is great for that. So grouping customers, grouping products together. So kind of clustering use cases. Yeah, those I would say would be the most interesting ones.
So for us, due to sort of our USP of being able to sort of put together fairly intricate, interconnected workflows, but also make this simple for your company, we've had a lot of sort of problems which would have been handled with very mature MLOps system. Individuals and organizations looking for help doing that. So for instance, you might have data in one location, then migrating it into MongoDB with some series of extraction tools, and then building chunks and insights, so extracting the structured data out of PDFs and even images, for instance, and then downstream of that, building vector search and RAG systems contingent on not just the unstructured data, but also the structured outputs. But and then also staying up to date with changing news, so that integrating deeply with, for instance, MongoDB's change streams, so that you're up to date always in your application. So something like building your own ChatGPT for your own documents, which are in a difficult place, and allowing this thing to be a real-time system, essentially. So that's a key use case for us.
Yeah, awesome. And just kind of to close it up before we do any last questions, I'm wondering for you all, over the next year, what's on the roadmap? What are you most excited about in terms of the AI world, and potentially what can your product do to help it?
Yeah, so I mean, we're a platform, so an infrastructure platform. So we tend to be excited about infrastructure.
Yeah.
Technically, the way you deploy on us is we're trying to provide a serverless experience where we auto-scale depending on your load. So we're trying to make it so that you don't pay for idling infrastructure, and which is highly relevant when you use GPU, which are extremely expensive. So we have the auto-scaling capabilities today, which are helping in terms of cost, and it's going to scale to zero on one end. And the other side of optimization for us is we're going to bring differentiated hardware, which is actually, from what we see, highly capable, and can actually solve the same problems as NVIDIA chips, but potentially for half the price. So, and because we know that still, usually the more parameters you have, the more precision you have, it means you can have some more accuracy for cheaper. So it's actually, and it just means so you'll need a bunch of tooling to use this, but at the end you will have even more capabilities. That's what we see coming up through our platform.
Yeah, very exciting.
Yeah, so I would agree with that. So I think cost is going to come down a lot. That's not just in the hardware layer. It's also going to be on the model side. So the model's getting smaller, and I'm excited about the Meta Llama models which are being released, and also the tooling around being able to host those with basically no incremental sort of additional marginal cost to yourself and your organization. So more power to the man, and then new algorithms. I mean, we must remember the LLMs are just one algorithm, and I think we're going to see much more in terms of agents being trained with reinforcement learning, and hopefully we'll finally get robots in the kitchen doing the cooking for us. So, and I would love to be part of that. So we would like to make. That's why we developed the platform, essentially to be future-proof against developments, because this is not about LLMs. This is about AI models in general, which essentially highly nonlinear functions from arbitrary input data to arbitrary output space of some type. So including vectors. Yeah. So.
Well, I'll have to agree, right? The more smaller models, cheaper to run, the more AI engineers can use them,
Yep.
and don't need to get huge budgets to build their applications. So that's definitely exciting. And then, I think more companies building working production grade applications, and then others need to build more of those. And so hopefully better user experience and better products, right?
Yeah.
And cooking, that would be nice.
Great.
Cleaning as well.
Well, thank you all for coming, and
Thank you.
thank you all for coming. I'm sure our panelists would be happy to answer any questions if anyone has them, but otherwise, we can wrap. Yeah.
There's a question.
You guys have talked quite a lot about model selection and the importance of model selection. But you've also talked a lot about how there are open source models which will obviously spawn more models and new models. And I think I read the other week that Hugging Face has now got something like 1 million models on it or something like this.
Yeah.
So is model selection not going to become more and more difficult as time goes on? And then how do you actually choose a model more accurately for your application?
Yeah, so I mean, you've got some various things. So there's metrics. So I think to pick the best performing model, it's rather easy because you go to the leaderboards and, as you said, look, one's there. And then for your particular application, there may be some differences between what the leaderboard says and what your particular application is. But in terms of, you have operational constraints as well. So how much are you willing to pay per token? What are you allowed to do? Are you allowed to send the requests to an API or not? Maybe you have some agreements, SLAs, that you have to have a turnaround time of. So then modulo the operational requirements, then you're going to have a set of candidate models, and then you're still going to take the first approach, which is to essentially subset the set of available models to those that meet your operational constraints. Hosted on device, on CPU, there's not going to be many that come into question. And then, there's still infinity of possible retrainings of those models. So maybe you want to throw in a fine-tuning subject to the proviso that this is something you have budget for. So there's a lot to do, but I think there's still a clear path, which is to follow the scientific method on the basis of the things available to you, run experimentation, and on a reasonably sized data set so that you don't burn your whole budget on the choosing. But downstream from that, you could be saving your enterprise millions of dollars and making yourself a very attractive AI engineer. So, yeah.
Do we have any other questions? Going once, going twice? All right then. Let's have a big round of applause for the panelists, please.